CLion a cross-platform IDE for C and C++. Download now.
Thanks very much, Pete. As soon as I sent Pete this talk, I put the title A Sixth Seam, and just like when you send an email, I immediately realized it's the wrong title. It should be called A Sixth Double, which made me think of the apparently famous last words of Dylan Thomas, who died in a bar, whose last words apparently were, "That's 19 doubles, I think that's a new record." So I'm John, husband, dad, and granddad, head of a startup called Kosli. We did our Series A announcement a couple of weeks ago. We're hiring like crazy because we're expanding. And Joshua, the way it works is you have to email me, okay? Right? Yeah. I've been coding for 30 years, but that is in Hex. A lot of you know me from Cyber-Dojo and from phishing. And I'm one of 3 chairmen, I believe, who's in the room. Ex-chairman at the moment, of course. So this is the idea. The majority of time, the majority of our tests are unaffected by the current work in progress. I think that's true. And so they would run much faster if we could use a cache that was auto-created at the seams from the previous time the test ran. If you don't know what a seam is, it's a term introduced by Michael Feathers in his tremendous book, Working Effectively with Legacy Code. Test calling A, B, and C there, your code for some definition of your. There's crossing of what he calls a boundary of trust into X, Y, and Z in this case, which essentially means they are pieces of code that take longer to change. And there's a syntax and terminology, I should say, for the various types of replacements that you get for replacing X, Y, and Z, which I've just described here as X bar, Y bar, and Z bar. So you'll probably know the terminology. There's 5 well-known doubles. They have specific names which you'll know from testing. See if you can get them. What's this one? Dummy. What's this one? Someone said it? No. Stub. What's this one? Spy. What's this one? This one's a bit trickier. It's a soup. What kind of soup? Might be a turtle, but it's not really a turtle. It is mock. And the last one? Fake. Brilliant. Fake watches. So this is the idea. To remind you, could we provide something that uses a cache, auto-created at the seams from previous times the test ran? What we're going to call it an auto cache, which is not that surprising if you think about it, because a cache is effectively a spy and a stub, if you think about it, okay? So this is the implementation idea. We get to run a test again if it fails. And the first time we try and use the auto stub to replay from the seam cache. And if we get to the second run because that failed, then we use the spy at the seam to build the cache for the next time. This is how it works in Python. We're actually doing this at Kosli. So we don't give our tests proper names, if you like. We give them IDs. And we use doc strings for what previously people put inside the long names of the tests. There's a reason for that, which we won't go into this talk, because that's a different talk. But the important thing is that you get a T as the argument. That's called a fixture. The implementation of that looks like this. It auto runs because it's got auto use equals true, so you get one whether you ask for one or not. That's important. And we do a yielding of the T object that we created in the with statement, and that's also important because it gives you our AII. So here's the T constructor. Importantly, the T object knows its own ID, so as the comment says, in this case, T.ID would be the ID of the test. And inside the test object, T, we have a cache. The entry and exit sets T for the individual test run. T is a global, yes. We could do this with thread local storage if we had to. And then at the seam, you replace, and here's the seam. You call across the cache. DB is the name of the seam. And with proxying, we can pass the real thing so that we can call that if we need to. Here's the run. Are we replaying? If so, we replay. Otherwise, we rebuild. Here's replay. Try and get it from the cache. If it runs out, it doesn't matter, and it fails, and that's good because you hit the second time. Otherwise, we rebuild. We literally just call the code, fill in the cache. I'm eliding the saving of the cache in the pickle files. And so it just works. The first time, when you run it, you're trying to replay from the cache. It fails. Second time it runs. How does it do it? There's a there's a library called runtime-failures designed for flaky tests. You just put this in your argument, and it works.
Thank you, John.